Good morning to all. In this video, we are going to discuss about the elementary data link layer protocols. Elementary data link layer protocols. These protocols are available in data link layer and it is designed so that this layer can perform the basic functions of the data link layer. The three main basic functions of the data link layer are framing, error control and flow control. Framing is the process of dividing the bit streams from physical layer into data frames whose size ranges from a few hundreds to a few thousand bytes. Error control is a mechanism which deals with the transmission errors and retransmission of corrupted and lost frames. Flow control regulates speed of delivery and so that the fast sender does not drown a slow receiver. For noiseless channels, we have two protocols, that is simplex and stop and wait protocol. For noisy channels, we have three protocols: stop and wait ARQ, go back and ARQ, selective repeat ARQ. Simplex protocols for noiseless channel. This simplex protocol is a hypothetical protocol designed for unidirectional data transmission over a channel. Here, as the channel is ideal, the transmission can never go wrong. It has a distinct procedures for sender and receiver. The sender simply sends all the data available onto the channel as soon as they are available its buffer. The receiver is assumed to process all the incoming data instantly. It is hypothetical since it does not handle flow control and error control. Stop and wait protocol for noiseless channel. This stop and wait protocol is for noiseless channel. It provides unidirectional data transmission without any error control facility. However, this protocol provides flow control so that the fast sender does not drown a slow receiver. The receiver has a finite buffer size with finite processing speed. The sender can send a frame only when it has received an indication from the receiver that it is available for further data processing. Stop and wait ARQ for noisy channel. Stop and wait ARQ is a variation of the above protocol with the added error control mechanism. The sender keeps a copy of the sent frame. It then waits for a finite time to receive the positive acknowledgement. If the timer expires, the negative acknowledgement is received, the frame is retransmitted. If positive acknowledgement is received, the next frame is sent. Go back and ARQ is for noisy channel. Go back and ARQ provides facility for sending multiple frames before receiving the acknowledgement for the first frame. It uses the concept of sliding window and so it is called sliding window protocol. The frames are sequentially numbered and a finite number of frames are sent. If the acknowledgement of the frame is not received within a time period, all the frames starting from the frames are retransmitted. Selective repeat ARQ for noisy channel. This protocol also provides for sending multiple frames before receiving the acknowledgement for the first frame. However, here only the erroneous or lost frame are retransmitted while the good frames are received and buffered. Elementary data link protocol is classified into three main categories as protocol 1, that is unrestricted simplex protocol. Protocol 2 is simplex stop and wait protocol. Protocol 3 is simplex protocol for noisy channels. Unrestricted simplex protocol, here the data transmitting is carried out in one direction only. The transmission is indicated as TX and the receiver is received as mentioned as RX are always ready and the processing time can be ignored. In this protocol, infinite buffer space is available and no errors are occurring in such a way that no damaged frames or no lost frames. Here the sender is A and the receiver is B. Upon receiving the request that the receiver is free, then the sender sends the frame. Here it is unidirectional. So the sender sends the frame from A to B. It never waits for the acknowledgement. It constantly sends the frame from A to B on receiving the request that the receiver is free. Simplest stop and wait protocol. In this protocol, we assume that the data is transmitted in one direction only. No error occurs. The receiver can only process the received data in a finite rate. The assumption implies that the transmitter cannot send frames at the rate faster than the receiver can process them. The main problem here is to how prevent the sender from flooding of packets to the receiver. Flooding means that when the sender is fast and the receiver is slow, the sender may send too many packets to the receiver. This process is said to be as flooding the receiver. The general solution to this problem is to receive the feedback from the sender. The sender has to receive the feedback from the receiver. Step 1. The receiver sends the acknowledgement frame back to the sender, telling that the last received frame has been processed and passed to the host. Permission to send the next frame is granted. The sender, after sending the next frame, has to wait for the acknowledgement frame from the receiver before sending the another frame. This is called simplex stop and wait protocol. Here the sender receives the request to send the frame. After receiving the request, the frame is being transmitted to the receiver. After receiving the acknowledgement for the frame, again this acknowledgement is treated as a request to send the next frame. So the next frame is being sent, and for that after receiving the acknowledgement, the next frame will be sent. Simplex protocol for noisy channel. It is also a unidirectional channel with finite processing capacity and speed at the receiver. Since it is a noisy channel, error in the data frames or acknowledgement frames are expected. Each and every frame has a unique sequence number. After a frame has been transmitted, the timer is started for a finite time. Before the timer expires, the acknowledgement is not received, the frame gets retransmitted. When the acknowledgement gets corrupted or sent data frames are damaged, how long the sender should wait to transmit the next frame is infinite. Here the request for the first frame is being received, so the sender sends frame 1 and receives the acknowledgement for frame 1. After that, receiving acknowledgement for frame 1, it sends frame 2. Now the frame 2 is being lost, and so it never receives the acknowledgement for frame 2. So it waits for a time period. After that, the frame 2 is being retransmitted again. Then again the acknowledgement for frame 2 is being received. Thank you.